So we saw what is total internal reflection, right? Now there are a lot of practical uses from TIR. Okay, so you will see one or two. All right. See, the first one is we use this total internal reflection in periscopes, in binoculars, and lot of cameras. All right. Now, how we use this is, see, using TIR, we can deflect the direction of light by 90 degree to even 180 degrees. Okay, now in a periscope is this particular instrument. See, in a periscope, we place two prisms. It's a 45, 45, 90 prism in these two places, okay, in the two corners. So what happens here is, instead of keeping mirrors are not 100% efficient. You guys already saw that. So what we do is we keep a prism and the light ray will be incident on it in such a way that there is total internal reflection. Okay, so here 90 degree shift of direction, right? In binoculars there is 180 degree shift of the direction of light. All right, so this is what happens. So here also we have 45, 45, 90 prism, but the ray of light is incidented in a different way. See, like this. So here you have 180 degree shift. Okay, and also in certain cameras, so what we do is we use this type of prism. So here if you look at it, the top is the bottom and the bottom is the top, correct? So here also there is 180 degree shift, but in the position of the image, not in the direction of light, but then in the position of the image. So these are all practical applications of TIR. Okay, in prisms, only in prisms. Okay, now by using TIR, we can explain, there is a concept called as mirage. So mirages happen only during hot weather. Okay, all of you would have experienced it. Like if you're, let's say you're going in afternoon in a very hot place, let's say in a road, then you'll feel that the air is moving, maybe like some water is there, right? So this is basically mirage. Now what exactly is mirage? You see, because of very high temperature, what happens, the ground will be very, very hot. So the density of air will keep on changing. As the temperature changes, the density will also change. So each and every layer of air will have different refractive index because of the density. Okay, so as the ray of light comes and, like from the, let's say from a tree or from the top of a building, let's say a ray of light is coming, then it undergoes multiple refractions. Okay, so it undergoes multiple refractions. At some point of time, what happens, the angle of incidence will be greater than the critical angle. Then it undergoes reflection. So this is what you see. Okay, so this is actually, it's a virtual image. All right, so that is what we call as mirage. So mirages could also be explained by TIR, and even how prisms are used, because in certain cameras we use pentaprisms, like 5-sided prism. So in 5-sided prism, the ray of light will keep on changing. Okay, so here this particular TIR is used, that is the angle of incidence will be greater than the critical angle. All right, so these are certain applications. There is one more application, optical fibers. So optical fibers are actually designed so that the ray of light will undergo total internal reflection, and we use optical fibers in almost all the scenarios. That particular thing you'll see in the coming video.